All right, it's time to get graphing. Now, I know some of you have told yourselves you're not good at graphing, and you're right. You can't be good at something if you tell yourself you're not good at it. So tell yourself a different story. How about you say, I don't know if I'm good at it or not, but I'm going to give it a chance. I have an open mind. So let's take a look here. First and foremost, I want you to become familiar with graphing a basic parabola, which is y equals x squared. And you know that if we just do these negative 0, whoops, I don't think so. If we just plug in negative 2, negative 1, 0, 1, and 2, so negative 2 squared is positive 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 2. So let's plot these points. Let's say that that's a 1 and that's a 1. So we've got 0, 0, 1, 1, and 2, 4. And of course we can use symmetry to graph these. So there is your graph, and you always write near your graph the equation y equals x squared. If you are going to move this graph, we're going to do a couple of things. We're going to learn to shift it. Actually, we're going to learn 3 things. We're going to learn to shift it, right, left, up, and down, which is called translating. We're going to learn to reflect it. So this is concave up, and sometimes it'll be concave down. And then we're also going to learn to stretch it. So it makes it tall and slim, or wide and pretty open. So let's first take a look at reflecting. So here is this. And when we plug these values in, negative 2, negative 1, 0, 1, and 2, we get negative 4, negative 1, 0, negative 1, negative 4, which is, of course, if that's 1 and that's 1, that's this. I'm going to make the dots really big so they stand out and you can see them. And that's y equals negative x squared. So basically what I want you to do is I want you to realize that in math, if you think of it as a language, there's lots of codes. And so a negative in front of x squared means reflect it down. Pretend that this is a mirror. So when it's up here, if it's negative, then it goes down here, like that, down here. So we know that y equals ax squared plus bx plus c. So if a, the number in front of x squared, is positive, then the parabola opens up, up. And if a is negative, then the parabola opens down, right? The vertex, just to talk about some language, the vertex is the lowest or the highest point, depending on the direction of opening. The concavity is the way the curve opens. So again, this is concave up and this is concave down. And it's kind of easy to remember with these little smiley and sad faces. When A is positive, it's concave up. And when A is negative, it's concave down. Okay? So here it's negative, it's concave down, and here it's positive, it's concave up. And then of course we have, this is standard form. This is called vertex form because we can see the vertex from this format. The vertex is that value and that value, so HK. And then the axis of symmetry is x equals whatever the x value of the vertex is. So in this case, x equals h. And that's just a line that goes right through the vertex. Okay, so now let's take a look at shifting that curve up and down. So we've got here, we know that we've got, it's a little bit too much, we don't need all of these, 5 is enough. So we know this is 4, 1, 0, 1, 4. And when we fill in these table of values, we see that this ends up being 9, 6, 5, 6, 9, and here it ends up being 1, -2, -3, -2, 1. And when we plot this, what we find is the following. I'm actually going to plot this on this paper. Hang on. So when we plot this, here's what we find. We find that this, the 5 points of y equals x squared are there. Okay. We find that these points, when we plug it in, are here. Just going to move that up. And when we plot these points and make a table of values, we find out that the points are here. See how I use symmetry to just plot all the points? And that's this one. So what we end up noticing as we do this is that if we take a look at these numbers that are following x squared, they basically just tell us we're starting with y equals x squared, and we're just going to bump all the points up 3. See? This up 3 is this 1, 2, 3 is that, this up 3 is that, and so on. These points on this curve are all y equals x squared pushed down 2. That's down 2, that's down 2, and so on. So there's no more need to plot points, right? You should be able to now just do this. Let's say they give you let's say they ask you to graph y equals 5x squared. So that's a 1 and that's a 1, just to have some scaling. So you know that the main parabola, you have to remember the main parabola, y equals x squared, these points are here. And you just move them all up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And gone are the days of table of values. Forever. That's it. That's all you need to do. Up and down. Okay?